This is the brief on electromagnetic torque and rotational dynamics. So, what are we really looking at here? We're breaking down the physics of how a magnetic field can actually make a loop of wires spin. It's the key to how things like electric motors work, turning abstract math into real physical motion. Okay, first, let's get the foundations down. When you run an electric current through the wire, it essentially pushes against the magnetic field around it. And the torque? Well, that's just the twisting power you get. Think of it like a wrench. The longer the handle, the more leverage you have to turn a bolt. It's the exact same principle. Second, you've got this crucial thing called the magnetic moment. Just picture it as an arrow that points out the loop's own magnetic direction and strength. And the math here simplifies into a really clean rule. The resulting torque is always sideways, totally perpendicular to both that magnetic arrow and the external field. And finally, this all leads to rotation. That torque forces the loop to spin, right? It creates this angular acceleration as it tries to find a stable spot. The twist is at its absolute max when the magnetic arrow is perpendicular to the field, at a perfect 90-degree angle. And it drops to zero when they line up. That's equilibrium, and that's when the spinning stops. So, at the end of the day, it's this silent, invisible wrestling match between fields that drives the entire physical rotation of the loop.